Number 1, balance the following in an acidic solution. So we have hydrogen peroxide. We're going to leave our hydrogen and oxygen in our first half reaction, and then we're going to have our tin in the next half reaction. Now we need to balance all elements other than oxygen and hydrogen, and they're balanced. Then we need to add water molecules to balance our oxygens. Now, because we have a water molecule here, all I have to do is put a 2, and then our oxygens are balanced. Now we need to go through and balance our hydrogens. We have 2 hydrogens on the reactant side here and 4 here, which means I need 2 hydrogen ions. Then we balance our charges. I have 2 pluses over here, and I'm neutral on the product side, which means 2 electrons on this side. I have a +2, I have a +4, I must need 2 electrons on the product side here. Now, I can just add them up. I'm going to leave my electrons off because they are balanced. And my balanced redox reaction would look like this. For B, we have a lead oxide. So lead is going to go in my first half reaction. If you end up putting lead in your second half reaction, that's okay. Just make sure you keep your lead with your lead and your mercury with your mercury. Now Hg2+, this is actually mercury 1. This is an aside for you. Mercury 1 exists as a diatomic cation. So it's a little unusual that way, but this is mercury 1. Now the first thing we do is we balance all of our atoms other than oxygen and hydrogen. Then we add water to balance our oxygen. Then we add hydrogen ions to balance our hydrogens. Now we balance our charges. I have +2 on this side. I must need 2 electrons on the product side. That makes this the oxidation reaction. And I have a 4+, I have a 2+. I must have 2 electrons on this side to balance this reaction. So now I add my 2 equations together in order to get my overall reaction, and I don't have to multiply either of my half reactions by anything because we have the same number of electrons in both half reactions. So my overall reaction is 4H plus PbO2 plus 2Hg reacts to form Pb2 plus 2H2O plus Hg22 plus. So for C, again, we're going to separate our half reactions, then analyze our electrons and add together. Balance your atoms other than oxygen and hydrogen. Add water to balance the oxygen. Add hydrogen ions to balance the hydrogen. Now we balance our charges. I have +14 on the reactant side for my chromium half reaction, and I have a -2, so I have a +12 over here. I'm just going to write that down for some electron record keeping. Then I have a +6 on this side, which means I must have 6 electrons on the reactant side. That means this chromium anion here, this is being reduced. That makes this the oxidizing agent. Now, I have 6 electrons in my reduction reaction, but I have 3 electrons in my oxidation reaction. That means I must multiply this entire equation by 2 so that our electrons balance. Now, in this case, I'm going to write down the electrons as well, just in case you need to see that step. The chromium half reaction is not being multiplied by anything, so I'm just writing that down as it is. Now I can eliminate the same things on both sides. I have 6 electrons on the reactant side and the product side, but I do not share water or hydrogen ions. So my final reaction is going to be 14H plus the chromate plus 2 aluminum reacts to form 2 aluminum cations, 2 chromium, 3 cations, and 7 water molecules. Number 2, identify the species that undergoes oxidation, that undergoes reduction, the oxidizing agent, and the reducing agent. Well, the species that undergoes oxidation is also the reducing agent, so this is going to shake out fairly quickly. So the species that undergoes oxidation in A is the tin compound. Remember, the species that undergo oxidation and reduction, as well as the oxidizing agent and reducing agent, will always be reactants. So the tin 2 reacts to form tin 4, but then there were electrons on the product side, so that means it was the oxidation. Then, of course, the reduction, the species that underwent reduction, which is also the oxidizing agent, is going to be the hydrogen peroxide. So for B, we had the mercury, which went from a 0 to a +2, so that was our oxidation, which is also the reducing agent. And then the lead compound is what was reduced. You can verify that with the oxidation states. The lead ended up being a +2, but it started at a +4. So +4 to +2, that reduces the number. So for C, the species that underwent oxidation, so the reducing agent, is going to be the aluminum. Aluminum went from a 0 to a +3. It increased its oxidation state. The species that underwent reduction, and therefore the oxidation agent, is the chromate. Number 3, balance the following solutions. So I'm going to start with A, and I'm going to pull out those half reactions. So the sulfur-containing compounds in one half reaction, and the copper-containing compounds in another half reaction. First thing we start with is balancing all of the atoms other than oxygen and hydrogen. And those are balanced, so we can move on. Now I'm going to balance oxygen by using water. I have 2 here. I have 1 here. I'm not really sure why there are parentheses here. I'm just going to clean that up real quick. Now we balance our hydrogens by adding our hydrogen ions. Now I know this says a basic solution, but I'm going to take you through the acidic balancing and then make it basic. I think that's a better exercise. So I'm going to count. I have 2 hydrogens on this side. I have 3 on this side. I must need 1 hydrogen here. Now we balance our charges. So we have a -2, we have and we're neutral on the product side, so I must need 2 electrons over here. This is my oxidation reaction. And here I have a positive and I have a neutral, so I must need 1 electron here. This is my reduction. Now, before I can make this an overall, I have to multiply this through by 2. Then I can add up my equations. Remember to distribute your factor through. And eliminate what's the same on both sides. So I can eliminate my 2 electrons. Now I'm going to subtract 1 water from both sides. That leaves me with 1 water left. And I can eliminate both of these hydrogen ions from both sides. So what I'm left with looks like this. We do not have any acidic components to this, so this is balanced in both basic and acidic. B, This is actually missing a water molecule here. So now we can balance. We're going to pull off our half reactions. Balance everything other than oxygen and hydrogen, and it is balanced. Now we're going to balance our oxygen. We have 2 oxygens here, now we have 2 oxygens here. Now we balance our hydrogen. Now we need to balance our charges. For the oxygen half reaction, we have a +4 on the reactant side, but we're neutral here, so we must need 4 electrons. And for the manganese, we're neutral, 2 electrons. So I need to multiply this manganese equation by 2 before I add it together. And I need to multiply it by 2 so that I have the same number of electrons in both of my reactions. Remember, when there are electrons on the product side, it's oxidation. And when there are electrons on the reactant side, it is reduction. I can eliminate what's the same on both sides, so the hydrogens and the electrons get eliminated, and then I'm left with my final reaction. Now there are no hydrogen ions to eliminate here, so this is balanced in both acidic and basic solutions. C. Now it looks like C is missing part, but we can fill it in with hydrogen ions. Now I know it says a basic solution. Remember, we will neutralize our base at the end. So we first start with our elements other than oxygen and nitrogen, and they are balanced. Then we will balance our oxygen. Then our hydrogen. Then we balance our charges. We have a 4+ on the reactant side for our nitrogen half reaction, 4+ and a -1, that's a 3+, and we're neutral, so we must have 3 electrons on that reactant side. So our top reaction in this case is reduction. And then our bottom one is oxidation. Now, in order to get our electrons to balance, we need to multiply our reduction reaction by 2 and our oxidation reaction by 3, which would yield us 6 electrons being transferred. We eliminate what's the same on both sides, so we just eliminate our electrons. We subtract 6 hydrogen ions from both sides, and we're left with 2 hydrogen ions. We do not have water on both sides, so then we can form the overall reaction. Now this is what it would be if it was balanced in an acidic solution. It typically says a basic solution, so now we have to take it one more step. We need to neutralize each of these acidic protons with the same number of basic hydroxide ions. Now what I do to one side, I have to do to the other. So if I'm adding 2 hydroxides to the reactant side, I must add 2 hydroxides to the product side. So when I add 2 H pluses and 2 OHs, I end up with 2 water molecules. So now I have this reaction to contend with. I do one more check of likes on both sides. I have water molecules on both sides. So I'm left with 2 NO3 minus plus 3H2 reacts to form 2NO plus 2H2O plus 2OH minus. And D, I have my half reactions. Remember to keep chromium with chromium, aluminum with aluminum. Your reactants stay on the reactant side and your products stay on the product side. First, balance all elements other than oxygen and hydrogen. Then add in water molecules in order to balance that oxygen. Then add in hydrogen ions. So I have 6 here, I have 3 here, I must need 3 here. 4 hydrogen ions to balance the hydrogen. Now we need to balance our charges. For the aluminum half reaction, I am neutral on the reactant side and I have a +3 on the product side, so I must need 3 electrons there. That makes this oxidation. For the chromium half reactions, I have a 4+ and a 2-, that makes it 2+ on the reactant side, and I have a -1 on the product side. So that means I must have 3 electrons on the reactant side. That makes this reduction. Now, because we have the same number of electrons on the product and reaction side of our half reactions, we can just straight add these together. No multiplying needed because there are 3 electrons on both the reactant and the product side. Now this would be the reaction for an acidic solution, but I do have hydrogens on both sides, so I need to subtract 3 hydrogen atoms from both sides. There we go. This is the complete reaction for this equation in an acidic solution, but because it specifically says a basic solution, now I need to neutralize those H pluses. So I need to add an OH for every H plus I have. What I do to one side, I have to do to the other. So now I'm going to have 4 H2Os on the reactant side. And then I will have 1 hydroxide ion on the product side.